All right, GCC, let's continue on with Chapter 10. We are now going to learn how to write reactions from words. Remember to include the physical states, in parentheses, an S is a solid, an L is a liquid, a G is a gas, and an AQ means it's dissolved in water. It's an aqueous solution, but that means it's in a beaker of water. Now you need to remember which elements, when they're by themselves, are solid, liquid, and gas. Like bromine by itself is a liquid, it's diatomic. Hydrogen by itself is a gas. You need to remember which elements are diatomic. Remember, have no fear of ice cold beer. So those are your diatomic elements. They get a little 2, like oxygen is O2. Subscripts tell us how many atoms are in the molecule, like water is H with a subscript 2O. Coefficients tell us how many of those molecules there are in the balanced reaction, and that's from balancing, like 3 H2Os. So see if you can write this reaction. Sodium reacts with chlorine to produce solid sodium chloride. Go ahead and hit pause. You should know what sodium is and chlorine is, and then sodium chloride is a metal and a nonmetal coming together to make a compound, so check your charges. See if you can write this reaction on your own now. All right, the first step, sodium is Na, plus chlorine gets a 2 because it's diatomic. Have no fear of ice cold beer, Cl2. And then we have our metal and our nonmetal. Sodium is a +1, chlorine is a -1. That is 1 minus 1, that already adds up to 0. So it's good. You need 1 sodium and 1 chlorine, NaCl. That's the first step. Make sure your formulas are correct. If you have a metal and a nonmetal coming together, you have to check the charges. +1, -1 for NaCl. Step 2, add the states. Sodium, you should know. When it's by itself, it's a solid. Chlorine, you should know. When it's by itself, it's a gas. Now, I told you solid sodium chloride because I don't expect you to know the state of a compound. So NaCl gets the solid. But the first 2 are elements, you should know them. Here's a question. If chlorine is diatomic, then why isn't it NaCl2? Why don't I take that 2 and just pull it over? Well, we just said chlorine is only diatomic when it's by itself. Now that it's with sodium, it's not diatomic anymore. And what governs a formula is charges. Na's a +1, Cl's a -1. It already adds up to 0, +1, -1. We don't need 2 Cl's. That would be -2. Then you'd have +1, -2. That doesn't add up to 0. So again, don't copycat. I call this copycatting. If you see that Cl2 and you want to bring the 2 over, that's wrong. Don't copycat. You never copy from the right side to the left side, or the left side to the right side. Never copycat. Never copy from the reactant chemicals to the product chemicals. So don't bring that 2 over. It's just NaCl, 1 Cl. So again, diatomic is only when elements are alone. It does not apply to compounds. Na is a +1, Cl is a -1. It already adds up to 0. No need for 2 Cl's. So what you were trying to do is balance. Remember, balancing is last. Now we'll worry about having 2 Cl's on both sides, but that's the last thing we do. Because there's 2 Cl's on the left side, we need 2 Cl's on the right side, so we put a 2 in front of NaCl. That gives us 2 NaCl's, 2 Na's and 2 Cl's. That fixes the Cl's, 2 on both sides. Now we got to fix the Na's. We've got 2 NaCl's on the product side, so we got to put a 2 in front of sodium on the reactant side, on the left side. That gives us 2 Na's now on both sides. So the whole thing is 2 Na solids plus Cl2 gas, arrow, 2 NaCl solids. Good job. Let's try another one. See if you can write out this reaction now that you've seen one. Aluminum reacts with bromine to produce solid aluminum bromide. Hit pause. Try this one on your own. All right. So the first step is to write the proper formulas and maybe the states. Just the formulas. Okay. So aluminum is Al, bromine is Br, and it's diatomic. Have no fear of ice cold beer, Br. So we get Br2. And then aluminum bromide is a metal and a non-metal. When you put them together, you have to check your charges. You can't just say AlBr and be done with it. It's a metal and a non-metal. You cannot just say AlBr and be good. You have to check your charges. Aluminum is a +3. Bromine is a -1. 3, 1. That doesn't add up to 0. We have 3 minus 1. So we need 3 bromines to go with an aluminum because aluminum is +3, so we need 3 bromines. 3 minus 3 is 0. Notice we did not copycat. We did not take the 2 from the bromine on the reactant side and bring it over to the product side. That is wrong. Copycatting is wrong. Aluminum bromide is AlBr3 because of the charges. The charges tell us so. All right, now let's add our states. Aluminum is a solid, you should know that. Bromine is a liquid, you should know that. And then I told you solid aluminum bromide because I don't expect you to know the state of a compound. All right, balancing is last. We need 2 aluminums on both sides and 6 bromines on both sides. Okay, we had that 2-3 combo, so we have to make it to the common denominator of 6. So on the product side, we need to put a 2 in front of AlBr3. That gives us 2 aluminum bromides, 2 aluminums, and then 2 times 3 is 6 Brs. So on the reactant side, we need 2 in front of aluminum, so there's 2 aluminums on both sides. And then because there's 6 Brs on the product side, we need to put a 3 in front of bromine on the reactant side. So 3 times 2 is 6. 6 bromines. Awesome. Let's try another one. Oh, again, reminder, first write the reaction with proper formulas. Once that is done, you can't change those subscripts. You balance last. Again, balancing is last. Don't try to do it ahead and don't copycat. Always check your charges. All right, now let's write the reaction of phosphorus reacting with oxygen to make solid diphosphorus pentoxide. Okay, pause, write this reaction out, see if you can include the states and balance it all on your own. Go ahead, pause. Hope you paused and worked on this. Here we go. Phosphorus is a P plus oxygen is O2 because it's diatomic, have no fear of O, ice cold beer. So oxygen's diatomic. And then I told you it's diphosphorus, that's P2, pentaoxide, that's O5. All right. We didn't have a metal and a non-metal in this reaction, so we didn't have to check the charges. P2O5 is given to you from the name. It's a covalent compound, not ionic. So we didn't have a metal and a non-metal coming together to check the charges in this reaction. Let's add the states. P is a solid, you should know that. Phosphorus is a solid. Oxygen is a gas, you should know that. And then I told you P2O5 is a solid. All right, balancing. 4 P solids plus 5 O2 gases make 2 P2O5s. Yeah, so I hope you got that balancing done correctly. All right. So here's a hard problem. I'm going to start the next video with the answer to this. See if you can do this one on your own. We're going to write then balance an aqueous reaction, meaning it's in a beaker of water. We have nickel 3 sulfate plus lead 2 nitrate produces nickel 3 nitrate and lead 2 sulfate. Whew, that's a handful. This is a hard one. Again, we'll start the next video with the answer for this one. Write this one down, pause, write this one down, see if you can write and balance this reaction. And I'll catch you in the next video for Chapter 10. So long for now, GCC.